The thing is, too, that a lot of mathematical patterns don't relate to reality, right? Like the Zeno's mathematical analysis does not relate to reality. Okay, that happens a lot. So if reality really were math, why wouldn't all of the math happen? I mean, math is math, and in math, all the math happens. So why in reality, if it was math, would not all the math happen? So there's reasons to think that this model is limited. I mean, not to mention that even in those places where it's not limited, you know, uh, in the way we think about it, it actually is. When you throw an object, it travels in a parabola, right? Well, no, because there's friction. And even in space, there's friction. Or even in a vacuum, there's multiple bodies. And so, because of the discrete nature of energy and time transfer, if you really break that down to get an exact path, it won't be a conic section. It won't even be a modified conic section. It will be some weird quantum path that you'll have to calculate on the quantum level. So, these mathematical patterns, they do beautifully well, but they don't actually describe real patterns. And insofar as they don't, then they're not better or, reality. It's just they are their own thing. They can't be, the perfect thing. Reality is imperfect, and they can't be like claiming to be underneath reality. Okay, they're abstracted on top of the information we get, just like everything. Now, this all made me think that okay, the shift that we're talking about philosophically, okay, the lowest level, you have this quantum theory that I said, which is that the model applies to the experimental evidence, that the model applies to the sense data that we can collect from what we call the real world, just by virtue of it being collected from the sense data. That's the first theory. That's the one that works so well. Okay, that people, even if they think it's nonsense, and there are plenty of physicists that think every interpretation is nonsense, and they'll even say, hey, you can't interpret it. Sometimes you can't interpret it. You just do the math, find the answer, use it for whatever you want to. Practical. Well, to me, like lowest on top of that, trying to give some more interpretation to it. Given that we need a lot of layers of interpretation that lead all the way back to what quantum mechanics might mean for us in our real lives, philosophically. Right at that level is something that is a shift in our perspective of how we model space. And it's a combination of quantum mechanics and calculus. Okay. And it has to do with the fact that we started with a point and line, and then a volume, and then just an abstract to an n-dimensional space, any number of spaces. So that's a point, right, with a zero dimensionality, and a line with one dimensionality, and an area with two dimensionality. And these are all volumes, and you can have n-dimensional volumes, okay? And a point is a zero-dimensional volume, and a line is a one-dimensional volume. All right. Now, this becomes, in calculus, the idea that there isn't really a zero-dimensional volume. Volumes are always of a dimension, and they always have an extent. They're always a volume. Okay, you could have an infinite volume of the whole thing, an infinite one-dimensional volume, but you can also have a one-dimensional segment. And you never need points, because what you have is not a point in that space, but a really small volume, or an infinitesimal, an infinitely small volume. And instead of thinking of it as a location, you think of it in terms of, well, I have a dimension, it's the infinite volume. And if I divide that up an infinite amount of times and get the smallest possible piece, what do I have? And I have an infinitesimal extent, always in some dimensionality. Okay. Quantum mechanics makes this assertion in calculus, okay, this geometrical assertion that underlies calculus on the physical world. It turns out that there is no location. Even if you take abstractions like the center of mass of something, these things are smeared out because of quantum mechanics. They're always in an interval of possibilities. So we just call them possibilities. They look more like this wave function is an interval of proportional actuality of which we see a cross section. Okay, we see a cross section. And so, in a way, quantum mechanics, that's what I was saying earlier, is that quantum mechanics is perpetuating the assertion that even if space is sort of blurry and whatnot, that some sort of a mathematical language, in other words, a language for speaking about patterns, can still be done. So things are not determinable, but that doesn't mean that we can't speak about patterns still. Okay. And the pattern that we need to speak of is intervals. Things always happen within a range of possibility. And you can apply this to philosophy all the layers up. Take language. Words are not points, a definition. It means exactly this. No, words are intervals. Some words like thing are big intervals with special features where they can collapse down and mean a smaller interval, depending on context. And, the most tight technical phrases still are intervals. The intervals are defined in terms of the intervals of the terms used to define them. And ultimately, all terms come down to sense statements about sense experiences, or metaphors taken from statements about sense experiences. Anyway, that's what it made me think of. That's why I watch YouTube, to have trains of thought like that.